This is Advent of Code 2020, day 18. The puzzle today is called Operation Order. And so what we have is a situation where we're helping out a kid with his math homework, or their math homework on the airplane. And it sort of works like the math we all know and love. Plus means plus, multiplication means multiplication, and parentheses help tell us what the sort of precedence of a particular group of operations should be. But that's where the familiarity ends, and where things get weird is the rest of the rules of operator precedence. We have to throw out what we know, and instead we just evaluate left to right. So in the situation of this string of operators here, instead of in traditional math, we would do the multiplication here first, and we do this multiplication first, and then we would add all that together. Instead, we go left to right, so 1 plus 2 is 3, times 3 is 9, plus 4 is 13, times 5 is 65, plus 6 is 71. All right. So yeah, that's the kind of math we have to do. And then you can consider if we had these parentheses here, we would, multiply these before adding it together. This innermost thing would be added before multiplying, so on and so forth. So we need to come up with a way of taking in arbitrary expressions like these and evaluating them according to that set of rules. Now, I don't really want to write a full-on sort of parser, tokenizer, interpreter for this subset of math with new rules, because that seems like a lot of work. So I'm hoping that because of how constrained the problem is, that we can maybe get away with just doing some fancy regex and that sort of thing. So yeah, I kind of like, let's see, I kind of like this as a starter example. I think it kind of got a little bit of everything. It's got plus and times. It's got some nesting of parentheses. So I think maybe that's a good starting point. So I'm going to copy that and jump over here. So we'll open up input. Well, no, we'll start with input. I'll just jump into part1.ruby, and I will create an expression, that right there. And yeah, we want to be able to start parsing that. And actually, just a real quick reminder for myself and everyone else, the sort of end game for all of this is we want to sum up the resulting values from each line, from each expression that we evaluate. So, if we were to evaluate these four, we would then add up 26, 437, these other two, and that would be the answer that we plug in here. Okay, so with that in mind, let's jump back over here. We'll have something that's like expressions. We'll eventually have to parse this out of an input file, but we'll say expressions, and it just gets that one for now. And then we will sort of say expressions.map. How do we do this? We can do symbol to proc with a sort of locally available method. I think it's method evaluate, something like that. That doesn't look quite right. Yeah, I'm trying to think. I know we did this in one of the earlier day problems. Maybe in 3. No. What about in 2? Ooh, I was close. Okay. Just got to get rid of that. Okay. So that's how we can evaluate an arbitrary method. So we'll have something that is like evaluate, and it takes in an expression, and it returns some value. So we can map these, sum them up, and return, or rather print that out, and that'll be our answer. Yeah, that's good. So before we go any further with this implementation, I kind of want to just start experimenting around in the in like a REPL. So yeah, let's pry in here and see where we can get. Okay. So the way I'm thinking about this is it would be nice to find any sort of isolated expressions like this, where it's parenthesis, some chain of numbers and operators inside of those parentheses. So if we could capture that, then run these operations, right? So 8 plus 6, and then that times 4, and then just replace this whole thing with that result. We have a new updated string with one less sort of nested parenthesis, and then we can continue to evaluate from there. And the reason I'm focusing on this fully nested one first is because if we are able to turn this into a number, well, suddenly this parenthesis to this parenthesis is a single sort of parenthetical expression that we can then evaluate similar to how we evaluated this one. And then once all of the parentheses are gone, we'll just be down to an expression of numbers and operators. And in fact, I kind of want to start with thinking about the numbers and operators part first, because that's kind of the base piece. And once we have a way of computing that, then we can get to the parentheses, and then I think we can glue it all together. So let's imagine expression 2, that is 5 times 9. We're kind of like doing a plus versus plus 2 times 9. So if we start there, yeah, what I would like to do is do like a match where we can sort of parse out the different pieces of it just using regular expressions. So I think we're going to have to make pretty heavy use of captures or even named captures in this solution. So we open up this regex, and the first thing I want to look for is a digit, actually maybe even just the start of the string, and then a digit, then a space, then some sort of plus or multiplication operator. Could be either or. Then another digit, and then the end of the string. So if we run that, we won't actually get a match because we match up to this point, and then we said that's the end of the string, and there's some other stuff here. So what I'm going to need to do is account for that. So maybe we'd say any number of digits, spaces, digits, plus multiplication, any number of those can follow. Okay, so now we match the whole thing. But we kind of just, we know we matched it, but there's nothing we can really do with the match unless we start pulling the pieces out. So that's where some captures can come in. So we can wrap those like that. these parentheses let us know that we have a capture, and maybe we'll even capture this last piece as well. So cool. So we just get positional captures. So we capture the 5, the plus, the 2, and then sort of the remaining stuff that we'll have to deal with. And I think we can make this even a little bit nicer to reason about by adding in some naming for our captures. So let's call this op1. We will call this, I guess, the operator. And then this can be operand 2. So the way the named captures work is the open and close parentheses delineate the capture, and if we lead that off with a question mark followed by a name inside of angle brackets, then that's the name that gets assigned to whatever then follows. So we've got names for each of these, and if this is there, we can call it just the rest. So if we run that, now we've got names on these things, and that's nice because then we can reference them like we do in a hash. So we get that plus. So let's jump over here and assign this to matches, I guess, for lack of a better name. And yeah, what do we want to do once we've gotten to this point? I guess we want to, we want to run this part of the expression, so 5 plus 2, and then we want to join it back together with the rest and sort of do the whole thing over again. And then the point at which we don't have, at which rest is empty, then we've kind of gotten to the point where we've fully consolidated the expression into a number, and that's the result. That's how I'm thinking about it, at least. So yeah, let's see. So matches to string is just the whole thing that gets matched. We say matches op1. So if we turn that into an integer, that's nice. Then we can do something like, normally integers will work, with a plus operator like this, and then you could say matches op2.2i, but we don't know if that's a plus or an addition or a multiplication. And instead of writing some sort of switch logic, we can take advantage of some of the dynamism and metaprogramming capabilities of Ruby. So we can do a public send of the operator like that. And then what follows is the argument. And if we do that, then we still get 7. And we didn't have to, sort of parse that apart and do any switching logic. So that'll give us our result. And then we want to update expression 2 to be equal to, this whole thing plus matches rest. And string can't be coerced an integer. So we need to, I guess, call 2s on this whole thing. And now we get 7 times 9, at which point we can run the same matches. And now we get 7 times 9, and the rest is empty. And if we run if we run this whole line again, where we take the operand, send to the operator with the second operand, and then append it to the rest. Yeah, we gotta, oh, there's the 2s. So if we do that, well, now expression 2 is 63, and there's, yeah, nothing else to do here. So I kind of like this approach for reducing down an expression that doesn't involve any parentheticals. So probably before we go any further, I should pull up some of these pieces into our implementation file. Yeah, I want the match, and I want this operator logic, so I will grab all of that, exit out of here, and call this evaluation. This is evaluate. And we'll probably need something more specific than that, but let's start with evaluate. Flat expression. I don't know what else to call something that doesn't involve any parentheticals, so I'm just going to call it that. And we're just going to take a string here, so the expression string. And now I will paste in these two pieces. Okay, maybe we can even create something like a little constant flat expression, and it's just going to get this whole regex here. That's kind of its nice own thing. So we'll call match on expression string. We'll get our matches, and then we'll run some operation. So operation result, maybe we'll split this out on its own line. Like that. And so then if there is a rest, then we're gonna keep going. Yeah. Maybe this whole thing is going to be like while true. Then we do this stuff. And if matches rest dot blank, then we just return the operation result. Otherwise, we add the operation result to the matches rest, and then we keep going. And yeah, infinite loop, that's fine, because it's not actually going to be. And what is it complaining about here? Sure, add an empty line. Okay. So evaluate flat expression. Maybe we can even just add a little raise standard error. No parentheticals allowed. And we'll just do if string dot, is it contains? Yeah, maybe I can do a equal like that, and we can say, does it contain either this or this? I think that'll work. Sure. Single quoted, how about that? Oops. Okay. I like the looks of this. Kind of want to jump down here and try it out. Actually, I think Ruby just evaluates all of the method definitions, so I don't need to put the pry down here. But yeah, I'm kind of curious to prove that that's true. So let's run this again. And okay, can I run eval u8 flat? Oh, maybe not. That's not defined. Okay. Well, I'm glad I tried that out. So how about here? Yep. Okay, now it's defined. So I can say eval u8 flat expression, and we can give it 5 plus 9 times 2. It's going to be 28, I guess. Undefined method blank for, oh brother, I keep trying to use active support things in a Ruby only context. Too many years of writing Rails code. Okay, so I guess if rest equals an empty string. Okay, if it equals an empty string, then we will break out. Okay. Undefined method for nil class. Where does that happen? Line 12. So matches is coming back nil. Okay. Yeah, that would be a problem. Well, let's put matches. That would be helpful to know what's going into there. Oh, I guess that's puts on matches is just going to call its toString, and that's all we're going to get out of toString. So that's actually not particularly enlightening. Yeah, let's just pry in here then. We run that. Oh, doesn't like the second pry? You want to finish 4 frames, but stack size is only 1. That is not a runtime error I've seen before. Okay, well, instead of doing that, what if we call evaluate flat expression with our 5 plus 9 times 2. Okay, so now we're in here, and matches is what I would expect it to be. So at what point did we have an issue with, oh, so it's looping, and then, oh yeah, that's fine. So if we exit, we get back here again. That's kind of what I was suspecting. And then matches is now nil because our expression string doesn't match the flat expression. And why would that be? Oh, because our digits, 2 characters. That's a great thing to catch. Okay. I'm glad we caught that now. So this can be any number of digits. This can be any number of digits, and that's implied by this times or this star here. So I think we're in a better spot now. If I were to ditch that and put it here instead, run this again, we can run this, and I think we will get 28 this time. Okay, that feels like good progress. We've got the pretty crucial part of this implementation figured out, which is evaluating the flat expressions. Now we need to figure out how to deal with the parenthetical expressions. So yeah, I think this is still a good place to pry in. Sure. So let's run that again. And now I want to imagine an expression that looks like 4 plus 2 times 2 plus 4, something like that, times 3. So that's a nice little expression. And what we want to do is identify this piece and pull it out. And maybe I can even take this a step further and nest that inside. Okay. So yeah, given this, I think we can do something pretty similar to the other piece. We'll say expression2.match, and we will define a regex where we're looking for somewhere in this string we want to find an opening parenthesis, then a digit of any length, and then a space, and then back to our either of the operators, another space, another number of digits, and then our closing parenthesis. And then we wrap up the regex there, and if we run that, yeah, we find this nested piece here. It doesn't get hung up on the outer one because it's not going to catch this one and then have another opening paren. It's going to find an inner one. So that's nice. And I think we can split some of these out into capture groups then. So this whole thing, in fact, right here and here, that's going to be our flat expression, which we can then send to evaluate flat expression. And so, yeah, once we do that, then we can, oh, I'm remembering something interesting we can do. So if I jump to the front and I call this my matches, matches.prematch gives us this opening bit, and then matches.postmatch gives us the closing bit. So we can say matches.prematch, add that to evaluate flat expression with matches 1, I guess, that's the positional thing. And then add that to matches.postmatch. Cool, so 2 plus 4 is 6. That just gets collapsed into a 6. And then we can kind of just keep going. So if this was called, updated for expression 2, then we could reevaluate the matches to get those. We could rerun this. Yep, so that's 2 times 6 is 12. And then I think it's at this point that we see that, yeah, if we run matches, we're going to get nil. So we know that we're out of parentheticals. So then we just need to run the whole thing, this whole expression, through evaluate flat expression one more time. And that will be our answer. And now, one thing I'm curious about, can I call evaluate flat expression on just a number? Will it know how to handle that? No, okay. So I think if if matches and flat expression comes out as nil, we just need to return the result, or we need to have a catch early, sort of a guard clause to recognize if we've just got an integer string coming in. So kind of a couple pieces I'm thinking about here, but the things I want to capture are the match and the expression update. So I've got that in my paste buffer. And then real quick, return expression string if expression string is a digit plus z. Yeah, that's a good guard clause. And now, yeah, this new stuff we've got is, I guess, evaluate parenthetical. I don't know if I typed that right. Parenthetical set spell. Yeah, seems like it. Set no spell. Cool. Parenthetical expression. And that's just going to take in an expression string. It's going to match the expression string. And if, yeah, like if matches, or, yeah, maybe we can say return expression string if matches is nil. Otherwise, we start doing some of this other business. So let's think through this. The expression string comes in, we try and match. If there are parentheses on here, then we skip past this return and we like build up a reduced version of the expression, set it as expression string. And at this point, we'd exit out of the whole thing, but I think we want to do something similar to above, where we say while true, and then, yeah, then we just keep looping around. And so eventually the expression string will be reduced to something that doesn't contain the parentheses and will pop out. Cool. So now, what does evaluation look like? We call, yeah, I guess step one is reduce out all parentheticals. Parentheticals. Yikes. We're going to find out later that I've been spelling that wrong, but that's okay. Step 2, reduce to a single number, and then just return that. So intermediate result, I guess, is really what we're expecting here is a flat expression. So evaluate parenthetical expression with expression, then result gets evaluate flat expression. And we're going to call 2I on this because what we should be getting out is a string that represents an integer. Well, instead we'll just return result.2I. And then, yeah, we evaluate all these. So expressions right now is this whole thing up here. I guess let's see if it blends. No parentheticals allowed. Okay. So how did we end up in evaluate flat expression with a parenthetical? Yeah, while this entire expression string contains parentheses, we should be reducing them down. So, curious to pry in here and see what happened on that first pass. Okay, so expression, that's what we expect. Flat expression. Oh boy. So evaluate parenthetical expression didn't reduce that at all. I wonder why that is. Evaluate parenthetical expression 2 plus 3. Yeah, that works. Plus 6. That seems fine. $11. Flat expression. I like what I'm seeing here, so I'm not sure how we bailed out of here early. What if I call this 11? What could this expression here be doing that isn't working, that's different than what this one's doing? It all looks kind of the same to me. I guess I'm not doing any multiplication here. Plus 4. It's just looking like it's working, so excuse me, what is going on up here? Seems like an intermediate step should be this piece and then the whole piece. So we match on any number of digits, any number of digits. That seems good. Maybe we can put out matches to H, I think is a thing we can do. And then I'm also curious to see what this is getting fed, because I think this should be getting called twice. That's a problem. Why is that empty? I mean, that's why we're popping out here with flat expression being unchanged. So while true matches if, yeah, matches must be nil, so we're just returning the expression string as is. Okay, well, we need to grab this and run this again. We're gonna just have to kind of debug this piece by piece. So expression, yeah, that's nil. Why is that nil? Expression. So there's an opening paren. Here's a digit. Here's a plus. Oh man. I see what's happening. I knew I needed to count for that too, and I guess I just got distracted earlier. So what we're missing is there's nothing to match on. Oh yeah. So we're explicitly matching on something on parentheses that are wrapping just a two, like a single operation expression. We're not matching on a 3 plus operation expression. Okay. So, I mean, the really naive approach that I think will just work because of how reliable our input is going to be is that we can do something like this. Any number. Yeah, now we've got a match. Okay. Well, let me get out of here, pop it back here and say matches gets expression string dot that, and let's see if it runs. 2s. Why did I think 2h was something you'd call on matches? Okay, so what does flat expression look like? And then we exit out, and that 12240. 12240. Okay. So let's take a look at this puzzle input. I'm going to copy all of that, jump back over here, and we should open up input.txt, paste that all in. That looks like it pasted nicely. Okay, so I'm going to jump back here. These are not our expressions. Instead, we want to read in a file. Like that, and then we can say our expressions are file dot split on new lines. And now I think we can get, oops. Binding, didn't mean to leave that in. I also don't really care for my puts wherever that is. Let's try that again. That is a number that I could see being an answer. Let's see. Awesome. We got a gold star. We just had to use a bunch of regex. Glad we didn't have to write a full-on interpreter for that. Excited to look at part 2 in the next video. Thanks for watching.